Last big block before we go to the coffee break is reserved to the EJP SOIL project's results. But we want to focus on what is relevant for policymakers. We asked the questions to Road for Schemes, Carbosec, Serena from Work Package 6 also, and Minotaur. This was prepared, this block, by the team of VP WP8, David Wall and Avion Phillips. I give the floor as first speaker, 10 minutes presentation only to Martin. Is Martin here? Martin Terseux, Road for Schemes. Can you just synthesize what is really relevant in the findings of Road for Schemes for policymakers?
Yes. Yes, and just before the slides come up, thank you very much for inviting me. It's super nice to be able to present all our findings, and also for the Commission. We started our work in the Road for Scheme projects before this certification framework was announced. So we were working the first year and a half in great expectation as to how will it play out, and what will be the outcome of all these activities. But we have tried to sort of develop our survey and our project so that it sort of also falls in line with some of these upcoming policy decisions regarding the certification framework. And I don't, this is for slides. Yeah. And then Road for Schemes consists of 10 European partners in the EJP SOIL, and you can see the partner list here. And the objectives of our project was to sort of assess what are the different carbon farming schemes that are in use across Europe. What are stakeholders' perspectives on these different carbon farming schemes, and also if we can work towards a roadmap for how we can further advance the carbon agenda across the member states. And this is where we are sort of working at the moment. So I'll present here our focus on the first two objectives. And first of all, and sort of building on the previous presentations regarding carbon farming, that there is, broadly speaking, two types of schemes that are used when we look at carbon farming. First, there are the activity-based schemes where farmers are rewarded for performing a particular activity in relation to carbon farming. That could be implementing a hectare of catch crop, for instance. And then you have the result-based schemes that are of a different nature, where farmers are supported based on the outcome of these activities. And this is where it really becomes relevant to have this certification framework, and also where there is a need for all of us in the soil science community to be able to document the effect of these different practices at field level. In our sort of, we have conducted a stock take of carbon farming schemes across Europe. And it is based on 180 carbon farming schemes in a broad survey where we try to uncover all the different schemes that are available, and then a more focused inquiry into 50 schemes where we have used a purposive sample to sort of clarify what is the variation in the use of different carbon farming schemes. And we broadly distinguish between three groups of carbon farming schemes. First, you have the farm payments that are sort of typically used under the rural development programs, where farmers are paid to do a particular activity. And then there's a range of schemes that focus on the corporate supply chain, typically where there, for instance, is a dairy that develops a carbon farming scheme, where all the members of the dairy need to comply with the different kinds of activities. And if they do so, they're also rewarded based on the activities. And finally, we have the voluntary carbon market, where there's typically an external certifier who certifies the carbon removal, issues a certificate that can then either be sold by the farmer or by a certifier in return for a price premium. And we have looked at all of these different types of schemes. So it's a bit, I suppose, broader than this focus on only the ones that go into the registry. Yeah, if we look at this inventory of 180 schemes, our good partner CREA has turned this into a web-based communication platform. So they will be available here over the summer. And it will be available publicly, and everybody will be able to sort of see some of the design features that are around when we look at carbon farming schemes. And broadly speaking, we can see there's most schemes in the northern part of Europe, and especially when it comes to these private schemes or the voluntary carbon market, they are mainly focused on the sort of northwestern side of Europe. We can also see that there is a great variation of different measures that are included in these surveys. Some schemes only support one measure. Other schemes don't really look at the measure, but rather how is the effect on soil carbon. But really, it's a broad diversity of different schemes in terms of different design features, and also in terms of the different kinds of payment models that are included. Yeah, and you could see this is a more in-depth focus of Denmark in this case, but we can look at all other countries in the same way and see how countries are distinguished from each other. And if we look at this more in-depth inventory we have collected of the 50 schemes in these three types of scheme elements, we can see that farm payments are mainly based on activity-based schemes, typically with a contract duration of just 1 year. So there's a lot of sort of focus on long-term sequestration. And also the farmers are typically not rewarded based on the amount of CO2 they sequester, but sometimes these effects are still included in the inventories for climate accounting and stuff like that by the government. So they tend to own reductions. And there is not that much focus on additional ecosystem services. It's mainly focusing on sequestering carbon. In the supply chain, we see a lot of different types of initiatives. Some are result-based, but there's also various types of whole farm approaches where there's not just a focus on carbon sequestration, but there's also a focus on other ecosystem services, such as protecting biodiversity, minimizing nutrient losses, and those types of issues. And in these types of schemes, the contract duration is also a bit longer, so up to 10 years. But there's also some of these schemes that are annual. Some are mandatory, for instance, for cooperative schemes to be part of. If you want to deliver your milk to a project, you also need to comply to various environmental performance criteria. And yeah, some of these schemes work with these additional ecosystem services. With respect to the voluntary carbon market, we can see that also in the expectance that there will be this certification framework, there's been a huge surge in different kinds of initiatives that have been popping up around different countries in Europe. Oh, yeah, I'm sorry. And we can see that they are very, very different. Some only focus on 1, 2, 3 farmers. Others quite a lot more, and this is really makes it quite difficult to compare across these initiatives because there is a huge variation. And if we can also see that the CO2 price, for instance, ranges between 30 and 500 euros, also reflecting that there is a focus on different kinds of measures for carbon sequestration. Some focus on high quality removals that have a long-term storage ability, and others, some schemes like catch crops that only have a very short-term duration and therefore doesn't really sell for a big price. But typically the farmers are quite involved in these schemes and also have an ownership and are able to have a business model out of this. We have also presented some of these design features to stakeholders, and I think that's super interesting because if we want to achieve carbon farming, it's also important that we have some carbon farmers, so to say. And we can actually see that there is quite a lot of interest from farmers to have an extra income. But for a lot of farmers across Europe, there's not that much focus on becoming involved in these result-based schemes. There's a lot of skepticism towards certification. There's skepticism towards whether or not the business model will be more rewarding for certifiers than for farmers, for instance. So in that sense, it's also important that going onwards, that this carbon farming certification doesn't only try to address the international markets for carbon removals, but also manages to bridge with farmers and ensure that their concerns are included in the design of these carbon farming schemes. And I think this was roughly the content of my presentation. So yeah, thanks a lot. And I hope we can talk more later.
Thank you very much, Martin Terse. 10 minutes, I must be really strict. Axel Don is the next one, presenting the relevancy, policy relevancy only from Carbosec.
Yeah, hello everybody. It's a pleasure to be here. And this one. Yeah, in the Carbosec project, we had a group of people discussing about the terminology of carbon sequestration. And I don't know if I get my presentation now. That would be great. And I want to acknowledge this group. It's also beyond the Carbosec group. But I need my presentation. I don't know if it's on the way now. Yeah. So maybe an advertisement beforehand. So Felix will present the results tomorrow at the poster session. So if you cannot follow fully, you can discuss with him. So we know that we are talking about carbon sequestration with different stakeholders, policymakers. We had it in the last presentation, scientific community, also the farmers, and therefore we need to be very clear what we are talking about when we talk about carbon sequestration, because there's lots of miscommunication potential, and therefore we need clear definitions of the terminologies. And if we look at the definitions, for example, from IPCC, we see that carbon sequestration is defined as the process of increasing the sea content of a pool other than the atmosphere. That's very general, is it? And that is clear. It's not precise enough for carbon sequestration in soils. And there's another definition coming from Olesen and al. And there it says carbon sequestration or soil carbon sequestration is a process of transferring CO2 from the atmosphere into the soil of a land unit. So it's getting complicated as well through plants, plant residues and other organic solids which are stored or retained in the unit as part of soil organic matter. It's also misleading because in the end, we want to sequester atmospheric CO2 as soil organic carbon, and it's also a bit too long and not clear enough. And therefore, we propose a new definition of carbon sequestration, bringing together the existing ones and making clear it's really the transfer of carbon from the atmosphere into the soil through plants or other organisms, which is retained as soil organic carbon. And that means we are looking at a flux of carbon. And we want to see whether scientists are already able to use this terminology correctly. And we looked at the newest 100 papers using the term carbon sequestration in soils in their abstract. And we found that only very few papers, less than 10%, really follow this terminology, because many of them look at a relative uptake compared to a baseline or a business as usual scenario, and not taking into account that we really need the transfer of carbon from the atmosphere. And we had also more than 40 papers, or 40% of the papers, that used carbon sequestration only as buzzword. So it's also widespread, but it should be used correctly. And you know, carbon is developing slowly, even if we don't do anything to the soil carbon. It can be either in steady state. Then it's easy. If we implement a measure, the difference between a steady state and the measured carbon, this is really the carbon sequestration. But in many cases, it's different. For example, if we have an increasing carbon stock under a business as usual or a baseline scenario, we only can account for this red arrow as the carbon sequestration of a measure. And in most cases, we have this scenario here. If we have declining soil organic carbon stocks, at least in croplands in Europe, if we look at the inventory data. And then it's the question, what is this? The difference between the upper line when we implement a measure for carbon enhancement and the business as usual. What is this here? Yeah, and we need to be clear, this one is not carbon sequestration because we only reduce the carbon loss. And therefore we said this should be called soil organic carbon loss mitigation. Or if you want, it's a relative C uptake compared to a business as usual scenario. And here also at the European Commission, we've seen that in Julio's presentation, carbon removal need to be very clearly defined because it's a removal from the atmosphere. And if it's compared to a business as usual scenario, it might be only carbon loss mitigation. And in this example, we have a mixture of carbon loss mitigation and carbon sequestration. So it's difficult, but we need to be clear on this. And even in scientific papers, we looked at it and we've seen that it's all mixed up. And we propose that if you do not get real carbon sequestration, you should talk about carbon accrual, or at least about relative carbon sequestration. Yeah, the definition is also important if we talk about carbon storage or carbon sequestration, because soil organic carbon storage has two meanings, and that's also difficult. One meaning is it's a quantity, it's a stock, carbon storage and carbon stock, it's the same. Or carbon storage is also used as an increase in carbon stocks over time. And this is also miscommunication potential. We need to be clear on this, and we propose the following. So carbon sequestration in soils is a global flux. So you really at global scale increase the soil organic carbon stocks. Carbon storage should be restricted to the meaning of carbon stocks to make it really distinguished from sea sequestration. And carbon accrual is a local flux, a carbon increase at local scale, which is not at the same sea sequestration because of potential leakage effects. Yeah, and if we look at the papers, we've seen that carbon storage is often also used similar to an increase in carbon stocks, so as a flux. And we propose to be more clear in the future on this. So we know there are these two meanings, but it's not good if one term has two meanings. So we should decide for one. Yeah, and if we go to examples of changes in carbon stocks or fluxes, we see that we need to be clear on all these different words: carbon loss mitigation, climate change mitigation, carbon sequestration, and negative emissions. And here for one example, oh, sorry, what was this? Can you go back, please? If we have more cover crops, we increase, no, it's gone. We increase the carbon in the soil, and we increase the uptake of CO2. And we can, with this, if we do not increase N2O emissions at the same time or other non-greenhouse gas emissions, we can really achieve climate mitigation, carbon sequestration, and negative emissions. and I hope that I get the last slide again, because it's really important that we distinguish between these 4 different terms. So carbon sequestration is not the same like negative emissions. I have to click through it now, sorry. But it's negative emissions means that you need to also account for non-CO2 greenhouse gas emissions. So here in this example, we have N2O emissions and CO2 uptake of a land unit, and we implement a measure. So afterwards, we have the similar N2O emissions, but more uptake. And therefore, it's climate mitigation, because we change into positive direction, more uptake. We have sea sequestration, so CO2 is always sea sequestration. And we have negative emissions because we have more uptake of CO2 than N2O emissions. In another example, it's different, because here we are losing carbon from the soil, even in the scenario before, and then we implement something to reduce the carbon loss. So we have carbon loss mitigation, less loss of soil carbon. This is climate mitigation, but it's no carbon sequestration and also no negative emissions. And we have even more examples, and we are on the way to write a paper on this and come along at Felix' paper and poster tomorrow to discuss this further, because it's complicated, but it's important that we are very clear on the terminologies. Thank you for your attention.
Quite confronting, and a big applause. Thank you, Axel Don. Antonio Bispo, where are you? Serena, indicator prioritizing. 10 minutes.
Okay, thank you. Okay, so I'm going to present you the vision we developed with colleagues. It's our vision. It's Serena, but it's also Siren, and also colleagues from Work Package 6. So we will define the concept of soil health and also discuss how it can be measured and evaluated. So first, I want first of course to thank my colleagues, but then within EJP SOIL, like Axel, we try to define the terms, and so we define several terms. You will find in the Serena report the blue terms we call the blue terms. So we define all those terms in Serena, and for soil health, in fact, we define soil health as the current capacity. I will come back later to that. We define soil health as the current capacity of a soil to function as a vital living system within natural or managed ecosystem boundaries and land use boundaries to sustain plant and animal productivity and health. Maintaining, I don't see it, maintaining or enhance water and air quality, and to further provide ecosystem services on the long term without increased trade-off between ecosystem services. We also define, well, soil fertility, but I will not read it. I will go directly to that point. We discuss a lot about what is soil health compared to soil quality, because we have 2 terms, and sometimes those 2 terms are used either the one for the other. And so for us, soil health is not equivalent to soil quality. And we developed the following figure to explain that. And in that figure, soil quality is seen as the capability of the soil to support in a sustainable way ecosystem services based on its properties. It means that it's linked to a context. It's linked to the soil type, to the climate, to the land use. And so it defines a potential with a sustainable use. And then soil, imagine that you have soil degradation or management practices that will limit or reduce the provision of ecosystem services, then this is the soil health. This is the current status. That's the idea behind. And of course, you can also increase the release of certain ecosystem services. You can increase the provision up to the soil capability, but this may have consequences, of course, on other parts of the ecosystem. That's the idea between that's our vision, the vision we developed within those different projects. And then we also develop other definitions like indicator, saying that it's a single or a set of variables to represent or infer a specific aspect to soil health. And then those indicators can be measured, of course, but also estimated or expert-based. And we also define very important terms, and just after me, Maria will come back to that. We define what is a reference value, what is a target value, and what is a threshold value, saying that these are very different, they have different meanings, and so we need to assess them in different ways. Okay. And then coming back to the selection of the indicators. To select indicators, we did first within the Siren project, we did a stock take. So we asked the members about what are the indicators that they are currently used in their countries. And so we identify and we try to classify those indicators according if they are trying to assess organic carbon, nutrients, contaminants, etc. And so we find, in fact, 68 indicators that are currently used in member states to characterize soil quality. The top 3 are carbon, texture, and nutrients and bulk density. You can see that biological indicators here are missing. Very few are used in the countries, and also organic contaminants. For chemical degradation, organic contaminants are not used in the different countries. And finally, we also try to think about a procedure or a process or a framework to select those indicators. And we said that we should think, we should have a top-down strategy coming from the policy needs, starting from the policy needs. Then going to what are the ecosystem services behind those policy needs. So here, for example, we have the different international or EU policy about climate. And then it's linked to different ecosystem services. And for example, here, decomposition and fixing processes. And then behind those ecosystem services, you have the different soil functions. Here, for example, natural soil fertility and the balance of soil organic matter. And then behind that, you have the processes. And finally, you can find the soil structural. And then that's the way to select the indicators relevant for different policies. That was the purpose. And we also identify that the guidance is missing for that. Whereas, for example, there is an ISO guidance to select specific indicators for the risk assessment for ecosystems. So the idea was also to promote that guidance. And finally, we try to apply that way of thinking to the selection of a minimum data set of indicators. So we cross the policy requirements. With the stock take, we also try to identify indicators that are used in more than half of the countries. And we also identify the indicators that were used or recommended in the literature and applied in different EU projects. And we end with that table. And this table is it's sort of a minimum list that should be, we think, included in the monitoring systems to monitor across Europe. And this minimum list will supply different policies. And we remember that we said that for organic contaminants and soil biodiversity and even water regulation, they are not included and not measured yet in member states. But I think, well, we recommend it to include those indicators in a first step. in the first year, sorry. Okay, so we introduced biodiversity. And just to conclude, to set up the scene about those discussions about definitions, indicators, selection of indicators, well, the story is far from being finished because you can access to two reports, so the Siren report and the European Agency report on soil monitoring and indicators thresholds. And we are in the process of developing indicators and thresholds in the Minotaur project and Serena project, but we are also drafting a new deliverable for Work Package 6 using all that information. And remember, and this should go to the European Soil Observatory, to the soil strategy, and feed also the European Soil Law. Remember that there are also starting projects, so the benchmark projects and also all for soil projects that will also give an input to that. And finally, at global level, there is also a discussion at FAO level on soil health indicators and the soil index, etc. So yeah, the story is not finished. That's our vision. That's the vision we developed within Siren, Serena, and Minotaur, but it's not the end of the story. So.
Thank you very much, Antonio. Very clear answer. We got some advices about your minimal amount of indicators to be taken account of. Maria, you made already the bridge to VP6. We have Maria van Tapia, who is going into details about the thresholds.
Hello. Is ready the presentation? So before that, I have the presentation I just introduced. Here it is. So this work also has been performed in collaboration between Working Package 6 and these 3 projects, which I see like sounds of our activity of Working Package 6. And so it's just this in the first one, right? Okay. So I will speak about different approaches to evaluate soil indicators. We were thinking in our activity that it is not just to define which are the soil indicators, but then also how to evaluate the status of soil health based on these properties that we indicate as indicators. So in this moment, we have found that there are 4 kinds of approaches that are currently in use. There is, for example, the approach to use fixed values. So in this case, there is some literature available on some static value, some threshold, as was defined by my colleague Antonio. But in this case, it is needed that some research has been performed to develop this threshold. So what is reported here is an example of what is published in the European Environmental Agency report on soil organic carbon. It is nice to see that they have applied this threshold based on pedal landscape situation, different ones. Going on, there is also another approach, which is based, the evaluation is based in relation to natural land uses. So this is something related to modeling. The idea there is to have a focus on some value that could be reached in agricultural lands by some measures that go towards a natural situation. So, for example, we have seen that it is proposed to have meadows as a reference for agricultural lands. Then there is an approach based on relative changes. So you just evaluate if your indicator is improving or not, based on some baseline. So in this case, you just measure a difference between a current status and what you have after the application of some measures. And then the final approach is what is proposed currently by JRC in the European Soil Observatory, just to have a distribution. So you may analyze in different pedo landscape the distribution that you have for some indicator property. And then you see and you define some threshold based on what is achievable in your specific region. So in principle, all these kind of approaches could be fine or not, so it depends. As I mentioned, this is what is applied by European Environmental Agency on soil organic carbon. This was based on a study that was conducted in Germany and neighbor countries. So the things there is that this threshold may be fine or not. So what we propose is that countries should test this that is proposed by a public entity based on their data sets to see if this is something applicable in their countries. Another application of threshold, a very famous one, is about soil erosion. Currently, if you go to the ESO dashboard, you see that for example, for soil water erosion, it is proposed to have 2 tons per hectare as a threshold. So this is based on an estimation on mean value for soil formation in European soils. But if you look in the literature, for example, in relation to water erosion, you can find very different kind of thresholds to define which is a risk area or not. So, and these are based on different approaches also to evaluate what is the risk of soil erosion. So also in this case, you have a wider literature and it's not so simple to define a threshold. But actually, this is what is proposed by JRC. And then again, this is what I mentioned you, that in the ESO dashboard, it was proposed to have this approach on distribution. So this is just an example on how it could go. So you have first to define a district, and also this is quite difficult because you have to define how a district is to be defined. If it is about administrative regions, like it is here, which is NUTS 2, or could be also defined by pedo landscapes or by water regions. So this is something also to be tested. And here I present you an application that I tested in my country, Italy, in the northern part of the country. So I tried to apply the European Environmental Agency threshold values on soil organic carbon on the left. And on the right, I applied a method based on reference values, so based on natural target value. And it is really interesting to see that you can see that the pop lane, it's not appearing on the right side. And that's because in that pop lane, finally, we do not have a reference value for meadows. So it is not that maybe these are not at risk, but probably it's due to the thing that we do not have a value to which to refer. So it is demonstrated that to apply this approach that in principle is very good one, you need to also to have some modeling and some reference values. So finally, we have done a very interesting activity in EJP SOIL to analyze which could be the pros and cons in the different approaches. And so we found that if some literature is available, some very good research done on threshold, it is not to say that this is not a good way to do, because could be very simple to apply and also to be understood by policymakers. On the modeling, as I told you, so the relative to natural land use, the problem there is maybe you do not have a land use to which to compare. So it is needed to have a very good modeling activity to apply this method. About the distribution, the problem there is that maybe your population of data set is not representative of the whole kind of situation that you can have. So you also have to test based on your data set. And on the relative changes, I think that in this case, it is essential to have a monitoring scheme. Otherwise, you cannot really analyze this. And I think that this could be really a good way to analyze at farm level, because in this case, you have real values. But then in the implementation at the regional level, there is also the other problem that when you do some mapping, you have an error in the mapping, in the digital soil mapping. So the error in the mapping could be much wider than what you can measure in the difference. So you maybe see and check also these aspects. So that's all by my side, and I hope this is interesting for the people here.
Thank you very much, Maria von Tapie, sorry. Stefano, Mokali, Stefano. Last one in a row, Minotaur biological indicators. Let me say already that Maria and Martin are joining the panel discussion after the coffee break. The others, so also you, Stefano, will maybe get some questions before the break.
Thank you very much. It's the same. So my presentation is a little bit linked to the one made by Antonio and Maria. I'm going to briefly show you what is going on within the Minotaur project. I'd like to thank, of course, Jack Faber, the colleagues from Working Package 6 and all the Minotaur consortium for the nice discussions we have within the project. The main goal of the project is to provide models, maps, and policy relevant biological indicators with validated reference values throughout 4 main steps. The first one is the data collection and harmonization. Data has been collected from EJP SOIL partners, but also from external sources and data sets. The entire information has been used for the selection of bioindicators, and this is what I'm going to talk today. And these indicators will be being validated under field conditions for their sensitivity, and the overall information will be used for modeling and mapping purposes. So we know that there are a number of different ecosystem services, and most of them are driven by soil biota. Despite the relevance of soil biota, actually, if you look at several documents provided from the European Commission or Mission Board, etc., several indicators have been presented for the assessing and achievement of soil health objectives, but as stated before by my colleagues, no biological indicators have been included in this list for different reasons. Actually, there's not any lack of indicators. There's a huge amount of indicators that have been used over in the last 2 decades across Europe. But the problem is that their application has been rather heterogeneous. Here on the right, you can see this picture taken from the EcoFinders project that has concluded several years ago, but the figure is still actual, where you can see how the few indicators have been applied in different ways, targeting different biological targets, using different methods, and so on. So the overall situation is really heterogeneous. And this caused also the lack of application of many indicators, as shown before by Antonio from the Siren project. So within the Siren project, there has been proposed as an internal survey within the EJP SOIL program and the member states to assess the implementation of such biological indicators across Europe. And the most commonly applied indicators were soil respiration, microbial biomass, and the use of earthworms, the assessment of earthworms, and as highlighted in green. As you can see here, the degree of the implementation is rather low. Just 6 or 7 countries has adopted this kind of indicators, and a lower number of countries has established specific criteria in terms of reference values, thresholds, and targets. So within Minotaur project, we decided to start from here and with a different vision. I mean, not different, but a vision which might start from the complexity of soil and starting from the assumption that the entire soil biodiversity, which account for about 1/4 of the entire biodiversity of the planet, could be classified into 3 main functional groups. The first one called chemical engineers, including most of the microbes, which are the key drivers of soil, the mineralization of organic matter, nutrient cycling, and so on. A second group called biological regulators, composed by microfauna and mesofauna, which has the key role to regulate somehow the biological dynamics of the previous group. And the third, last but not least, the ecosystem engineers, composed by macrofauna like earthworms and so on, that has the main role to shape and modify the soil structure in order to make it a good place for the other organisms, but also improving the soil fertility and plant production. These groups are not going to work separately. They are strictly linked. They collaborate each other to promote and guarantee the soil processes that are essential for the provision of ecosystem functioning and services, including also food security and human health. So we decided to select indicators specific for at least all the 3 groups of organisms that I've just showed you. So we decided to propose a 2-tiered system approach for biological indicators, where in the first group, which should have the highest priority, we included both functional and structural indicators selected from the literature. So they are scientifically based, cost efficiency, based on their cost efficiency, of course. We also guarantee that check for the availability of standard methodology for each of them, and of course for their sensitivity to most of the degradation processes. So this is a minimum data set of indicators that could give a general but relevant essential idea of the health status of soil from biological point of view. But of course, there's also a second group which include a lot of indicators. There's a huge number of indicators that could be used as optional indicators for different purposes from different member states, of course, according to the final purpose of the measurements and so on. So the list is still, both lists are still under discussion, but this is the general approach we are promoting. So general recommendation we'd like to give is that the entire minimum data set of indicators should be applied together. So the use of a single indicator might be really misleading. A common example is to consider an healthy soil, a soil which has a high amount of organic carbon, indicating a high level of biodiversity, and a consequent good status of health. And this is not always true, of course. It depends on a number of different situations, and there are several healthy soils with a low amount of organic carbon. So in general, we promote and recommend an holistic based approach based on the integration of multiple soil health indicators, including biological indicators, but also chemical, physical, and so on. So usually I conclude my presentation with an example I'd like to give to my students, comparing soil with a city. So if you aim to measure the health status of a soil, measuring, for example, soil respiration, the CO2 emissions, it's okay. This is useful to say, okay, that soil is alive, but nothing else. So it's difficult to say if a city is healthy or not, based on the gas emission of that city. How can you compare two cities in terms of soil health, comparing the CO2 emissions without knowing the number of citizens, for example? So the same for soil. So we need to know the amount of biological organisms that are responsible of the emission of that amount of CO2. And this is not enough. This is not enough because, okay, we can have an important information, but still we don't know anything about the substrate that or the processes that are responsible of this kind of emission, or which organisms are involved in these processes. So we need to provide additional information in terms of functionality, and we propose to use enzyme activity to try to figure out which processes are mainly involved in these processes in order to get a general preliminary but important idea of the functioning of such soil. And of course, the last information we miss is who is doing what. So we need to add, we need to add also information related to the main actors of these processes. So the chemical engineers, biological regulators, and ecosystem engineers, who are the main driver of the overall system and guarantee the health status of soil. Of course, these indicators should be contextualized. So doctors need hospitals to work, streets, devices, and so on. So all the biological information should be included and integrated with the overall metadata coming from other soils. So in conclusion, I can say, I have 30 seconds, okay? I don't have the time. So we have standardized and scientifically proven indicators, cost-effective biological indicators. So we just need to select the most useful for our purposes. So we propose this two-tiered system for biological indicators. So we are going to describe the criteria and the detail of this group of indicators in the deliverable 6.5 of the working package 6 that should be ready very, very soon. We recommend to use both functional and structural indicators for planning solutions and restoring actions under degradation threats. We can recommend again to apply biological indicators into a specific context with chemical physical data with an holistic basis approach, including biological, chemical, and physical indicators. And just a few comments about what's going on in terms of definition of models for the provisional models for the application of such indicators, validation, refinement of thresholds, but first of all, the establishment of thresholds and target values. So thank you for your attention.
One moment. We have time for one or two questions for either Stefano or Axel. Axel, come forward. And for Antonio. Antonio, are there any questions? Because we do not see them back in the panel discussion. There is a second microphone. Please switch it on already.
Thank you, Sophie Teichmeister from Austria. I have a question to Stefano. Did you think in the Minotaur project about standardized time points for sampling and sample preparation, because this is essential for any biological indicators?
Good question. Stefano.
Yeah, sure. Okay. We did not include any standard preparation for the biological analysis because each method needs different methodology for sampling. So we assume that within each proposed and recommended methodology or indicator, the sampling method will be described. For example, for mesofauna or for earthworms, we need a different approach for sampling. For microbiome, another one, and so on. So in Minotaur, at least, we discuss about this, and we will propose to include this relevant and key information within each method for this reason. I don't know.
Okay, thank you very much. Other questions? Oh, here. I'm sorry. Bye-bye. Somebody from home.
So thank you for the presentations. We have a question from Eduardo Constantini to Stefano. He wants to know which place do you see for the classic CN ratio, which is present in all SOIL databases?
Sorry, could you repeat? CN ratio? If I include it, we are going to include this in the. Okay, this has been discussed, but considered not closely considered like a biological indicator, but still relevant. So it's biological related. So we did not include it in the first year, but of course is a relevant element to be used for integrating with the biological indicators selected in the first group. Yeah.
No further questions. We lack some
Over
coffee.
there.
More.
Over
Sorry.
there.
And two more. The last two ones. Here? Yes.
Good afternoon, Marta Goberna from INEA, CSIC in Spain. Axel, I was really thinking about your terms that you're proposing, and I totally agree we need clear terms, but I think I don't agree that this is going to allow communicating better with farmers, politicians, etc. I mean, carbon sequestration, storage, accrual, carbon loss mitigation, it's lots of complex terms, I think.
What do you propose?
I'm certain we could have a full debate about that. I mean, we could dedicate hours. Scientists, we love terms, and we could really talk about that. But I think, why do we have to keep carbon sequestration only for global rates? I'm not totally sure about that.
Two questions.
Yeah, thanks for this question or comment. I will give you an example. For example, farmers who want to decide for a carbon farming scheme with certificates on their buildup of soil organic carbon, they need to know that there's also the possibility that the baseline carbon trends are such much declining that they will never achieve an increase in carbon. So we have global warming, we have increase in temperature that might really destroy soil organic carbon in a business as usual scenario. And we need to communicate to them. And if they, for example, think we can increase the carbon and I can generate climate positive products with this, then the communication was not correct. We need to tell them, yes, you can do something for helping to maintain or maybe increase your carbon, but we need to be very clear that we do not tell them, yeah, it's very easy that you can sequester carbon if he's, for example, in a situation that he's losing carbon in a business as usual scenario. I know it's complicated, but there are many products out there that even claim climate positive agriculture products. And the question is it really possible? And what is the basis you judge on this? And it's too much greenwashing out there, and the farmers need to be the first one to really be informed. What can they do, and can they really be sure that they're on the right track? And this has something to do with communication. So if they in the end think we can help to save the climate crisis. Then they also need to know, so to what extent can they help, and not to overestimate their contribution or the contribution of soil carbon sequestration to this climate mitigation issue.
Okay, I think you do agree that communication and definitions used within the scientific world should be better, and then the communication towards farmers is still another thing. But also there, the ambitions of both of you are huge. Last questions. Last question or questions?
Question, so very short question. I am Jerzy Grabiński, into dialogue. So my question concern of which indicator is the best. I know earthworms, but other in contact with farmers. What do you think? Why my question is that in the dialogue program we have to make something for farmers, guide simply. So we have to choose the best. Earthworms, of course, but which other? Perhaps you know. What is your proposition? 2 or 3 more? There was only 3. Okay, thanks.
Maybe I can ask you, what is the one indicator for human health? You will say, I need different parameters to assess human health. So for soil health, it's the same, just not one. So I think
No. Maybe 2 or 3. That was the question.
Okay, but only the biological ones, or
Which are
or all kind of indicators?
biological indicators?
Is it only
Biological earthworms, you know, is the best in contact with farmers, yes, because we have to prepare such guide for farmers, so we have to choose. So we have a problem. My question is,
okay? So only biological,
The feasible and useful ones. Which are they?
Okay, there's not the best indicator. So earthworms is a compromise. So okay, with this is why we propose to use the entire minimum data set together to have a first picture of the situation. But then, of course, depending on the purpose, but depending on the final goal of the measurement, you can add optional measurements or additional indicators. Another question that we are discussing about is it's better to propose an easy indicator, easy in terms to be done technically, but difficult to interpret in terms of interpretation. So maybe it would be better to propose more complicated, let's say, method, but easy to understand for farmers, for users, and so on. This is under discussion, and of course, it's not that easy. There's not a unique answer to that.
We don't know yet is your answer.
yes,
Yeah. But it was a very good question. Thank you very much. I give the floor. Thank you. Is it a short question?
Okay, so Melissa online is wondering, what do you think about the financial information that should be included? How much money the farmers could save, or that could be more acceptable by them to contribute to the climate change?
This is a question that maybe, Antonio, very short, but we can take this question also, or Axel, very, very shortly, because we can take that to the panel discussion later. It will be answered for in the panel discussion. Thank you very much, Stefano and Antonio and Axel and Antonio.